So this is my Evo Rage gimbal, which I think is just rebranded Xingyun Crane. And in this video I'll be looking at hacking the Bluetooth to see if we can actually control this gimbal without using the phone application. So the first step is to capture the Bluetooth traffic between the application and the gimbal. To do that, we need to enable developer options on the Android phone and find Bluetooth snooping log option and enable that. Next thing is to open the application that connects to gimbal and to connect actually to the gimbal and open the controls options. In the controls options, I went through every single button the application offers, so I can actually capture every single command which can be sent to gimbal over the Bluetooth. In my case, the log file was created in SD card /Android/data folder on my phone, so I used File Explorer to get the file off the phone and onto the computer. Once I've copied the log file from the Android phone over to computer, I renamed it to .pcap and opened it in Wireshark. And the next thing is to find actual commands. So if we go halfway down, and we can see the protocol is ATT, and what we're looking for are commands coming from the source localhost, go into destination, in this case that's the gimbal's name. And if we expand this last section out, we are looking for, in this case, for this gimbal, for this handle, so 0x002C, and that is the actual command sent from the Android phone over to the gimbal. So to build up the command list, first thing we need to do is let's have a look, apply filter and select it, which gives me this name. So let's clear the filter and right click on the bar and edit column. This is where we paste in the value, and this can be called whatever. I'll call it command. Yep, command. And we can see now the commands are here. So next thing, we need to filter on the handle, and let's apply the filter. So these are all the commands sent from the phone to the gimbal. And the last thing to do is to export as CSV, and I've already done it, so we just save over the top. And next thing we will be looking at how to build up the command list. Next step is to prepare for the script file. So what I've done there, obviously it's not the best option, but when I was doing it I just wanted to get over with it as quick as possible. So this will be the command we use, so this will be unchanging across all the different commands we're sending, and I'll just need to drag it all the way down. Then select the two columns, copy them and paste them in Notepad. Next thing is to replace the tab key with space, and now we can take these commands and send them to the gimbal. So the next step is to configure the Bluetooth on, in my case I think I'm using Banana Pi. So I actually plugged in the Bluetooth 4 USB stick, and first step, let's just actually do su, is to check that the Bluetooth is actually working, recognized. Next thing would be to install these apps. In my case they're all installed except this one, which actually I don't need in this case. And let's scan for the Bluetooth devices. In my case I can see this is my Crane device, and now it's time to connect to it. The next step is to connect to the Bluetooth device, and we can do it with these commands. We start application and tell it to connect to the gimbal. Next we can copy some of those commands we created earlier in the notepad and paste them in, and you should be able to see the gimbal starts moving. So if this happens, you just need to reconnect to the gimbal. I noticed that it does disconnect quite a lot, so let's just do it twice, and let's copy some of these commands again. It's disconnected, which is fine. We just need to connect again. Another tool which can be used for Bluetooth debugging is this Android application, which actually shows different services the Bluetooth device has to offer. The arrows down mean that the information can be retrieved from the Bluetooth device, and the arrow up means that the information can be sent to the device. To find out which UUID we need to use to send the commands, we just need to connect to the gimbal. And as we noticed earlier, we are using 0x002C to send the commands, so this is the command we need to use to actually find out what is the UUID where using Android app we could send the commands. Once I worked out which UUID is used to send the movement commands, I was able to move the gimbal using this application as well. The original commands I captured made the gimbal move in very big steps. I think that by capturing Bluetooth traffic from time-lapse function in this application, commands for smaller, finer steps could be retrieved. Thank you very much for watching this video, and I hope it helps someone. My next step is to build wireless remote using ESP32 board, so I don't need to use the apps on my phone, since, for example, motion time-lapse function uses up phone battery by having the phone screen on while the time-lapse is running. And another idea for the future would be to combine this gimbal with Raspberry Pi and OpenCV to build a rig that moves the gimbal to follow the subject in the frame.